In this video, we will continue with solving the exercise that we have started with in the previous tutorials. Now, we have reached to a point where we know the value of k, which is 1.75. So the equation is going to be p is equal to 1.75 t squared plus t plus 1. Now, for t is equal to 4, p is equal to 1.75 into 4 squared plus 4 plus 1. And that would be 28 plus 5, which is 33. So when we have 4 days, the amount of bacteria would be 33 millions. Now for t is equal to 6, 1.75 into 6 squared plus 6 plus 1. So it's going to be 70 plus... So when we have 6 days, it's going to be 70 million bacteria. Now for t is equal to 8, the answer would be 121. Now for the final variable, for t is equal to 10, 1.75 into 10 squared plus 10 plus 1, the final answer would be 186 million of bacteria. Now that we have the amount of p in every variable, we have to draw a graph of p against t. And when we say p against t, that means that p is going to be on the y-axis. So there you go. Let's plot the points. For the first 2 days, so on day 2, we had 10 million bacteria. So the first point that we're going to have to plot is basically on x is equal to 2 and on y equal to 10. That would be our first point. Now for the second one, we have x equal to 4 and y equal to 33. For the third point, x equal to 6 and y equal to 70. For the fourth point, we have x equal to 8 and y equal to 21. For the fifth point, when x is 10, y is 186. And for the final point that was given, when x is equal to 12, y is equal to 265. Now, we connect the dots to form our curve. And notice how the days and the amount of bacteria are proportional. When the days increase, the amount of bacteria increases.